This is a parametric runtime model I've made with Archimatix. I've exposed several parameters, which I can set with these sliders. And then the geometry is rebuilt or regenerated. I'm not sure what the difference is when I click the rebuild button. This demo is online. It's called Magic Gables. It's on my itch.io page, and I'll put a link in the description. If you're a beginner to Archimatix or curious, this video will give you an idea of what you can do with the runtime models, but I'm not explaining the interface or the tools. I'm assuming you already understand the basics. If not, there are tutorials on communityarchimatix.com to help you get started. Now, this video is about making a model smarter by adding logic nodes with turtle scripting, and it will work on any runtime or parametric models. You don't need to be an expert. This video will be pretty easy to follow, I think. This builds on my last Archimatix tutorial, Expressions and Math Functions. That video is more of a how-to, whereas this is an approach to problem solving. But I'm not showing any math, and I will be only showing pseudocode to keep things simple. Now, before I show what's going on under the hood in my graph, let me tell you what is so amazing about this model and what it's doing that makes it smarter. So I've made a logic node with TurtleScript, and let's be honest, it's not that smart, but it is smarter than the other nodes. So I've got a logic node which is driving other nodes on my graph, kind of like how a crank turns gears. So let me break down what's happening. The defining feature of this little cottage is the gabled rooftop. My TurtleScript applies onboard logic to determine which direction to orient these gables, and it works like a switch. It's either or. The model compares the two incoming floor plan parameters, and it only creates roof sections on the long walls. It leaves the short ends open, and it adds these gable end walls instead. When the parameters reverse, the smart node changes the direction of the roof and switches the end walls to the shorter side. The logic is really basic. It's just an if greater than conditional and the corresponding if less than. Based on that switch, the TurtleScript draws a 2D shape. It draws only the long walls and skips over the short walls. Now this open shape becomes the plan for the roof and these little stone walls supporting it. As an optional feature, I added this magic gable parameter that adds a third gable and also this end wall with a doorway. How about that? A doorway. Okay. The magic gable appears halfway down one of the long walls, the side that just happens to be facing the camera. If you're curious how I made these roof parts, I have a PDF tutorial on the Community Archimatix website called Dome and Rooftop Fundamentals, and that goes into detail about how to construct rooftops and gables like this. Now, before I explain how the logic script works, I'm going to have to explain parts of my graph. And if you're new to Archimatix, this might look intimidating or confusing or just cryptic. But this graph is actually on the smaller side. Now, typically nodes flow left to right. At least that's the easiest way to connect them. This model uses 7 materials. And when I add a new material, I usually drag the material node over to the left, and that helps me identify where I am in the graph. I did tidy up these nodes before I showed them to you, so this is more organized than usual, but my graph is roughly organized into the meshes that use different materials. For each new mesh I create, I have another row of nodes. These green textures are the grass. This is the roof. Here are the gable end walls and the windows. Now, sometimes I get comments about using multi-materials on an Archimatix model, but you need to remember runtime models are not prefabs. This is a collection of runtime meshes. We're destroying and creating geometry at runtime. So I'm not atlasing one big texture. Instead, I'm using lots of low-res tiling textures. And I've tagged the meshes to batch, and I've marked them as static. I realize a lot of this sounds counterintuitive, and I'm not here to argue about it. These aren't prefabs. These are runtime models. There's no geometry saved in my project. This is all fresh geometry created live in the scene. So again, what I'm doing is I set the meshes to batch. That allows Unity to group them as needed. And I set the model to static. Even though it's occasionally being regenerated, it isn't moving around in the scene, and Unity doesn't need to track its position of every frame, so that makes it static. All right, I'm going to turn off the various parts of this model by disabling the mesh nodes on the graph, and we're gonna start from the bottom and work our way up. So I started with a rectangle node, super basic floor plan, and I even named it floor plan, and exposed the two parameters, the height and the width. Now I've routed the floor plan's parameters into my custom logic node, which I've renamed Magic Gables, but it also began life as a regular rectangle node. It's reading the floor plan's height and width, but it's only drawing the long sides of the rectangle. When the values are flipped, it still only draws the long walls, whichever ones they are. Now this is my smart node. Inside this node, in its logic area, is where I've put my custom turtle script. The original rectangle draws a box with 4 sides. Now, actually, if you look inside, it draws 3 sides, and then it closes the shape for the 4th side. My custom node is an open shape, and I'm going to write my logic script over here. And it looks something like, if the width is greater than the height, do turtle stuff, and if. Now in Archimatix's version of TurtleScript, there is no else condition, so I need to create the complementary conditional. If the width is less than or equal to height, do some different turtle stuff, and end if. Now obviously this is not actual TurtleScript, this is pseudocode, so it will be easier for us to follow. And I'm also I'm just going to describe to you what turtle stuff means rather than show the actual scripting. If the width of the floor plan is greater than the height, our imaginary turtle draws the top and the bottom, leaving the left and right sides open. When the width is less than or equal to the height, only the left and right sides will be drawn. The top and bottom are left open. So in pseudocode, when we're just kind of planning out what the turtle needs to do, it's going to look something like, first, start at the bottom left corner. We're going to draw the bottom, skip over the right side, draw the top, and then skip over the left side. Now that's when the width is greater than the height, but if the width is less than the height, we're going to skip over the bottom, we're going to draw the right side, skip over the top, and draw the left side. Now I'm going to turn on the little stone walls, and we can see how this is working. My rooftop is also going to use the same plan. The roof sections touch down on the stone walls, and it leaves the short ends open. Each half of the roof needs to be half the width of the short wall, and this is a big tip for you. I call this the short wall rule of rooftops. And when you are making a gable or a hip roof, doesn't matter what the floor plan, it can be an elbow or even a compound shape, find the shortest wall and set the roof section to half that width, and your roof will fit. You'll have a big hole in the middle, but all the way around your roof will fit, and you'll have no overlapping rooftop. Now on my cottage, how do I know which side is the short wall? It's going to switch sides. So I added a new parameter to my logic node I named it gable span, and I'm setting its value right in my logic script. So I'm going to insert 2 lines in my pseudocode inside the conditional blocks. And I'm just going to set the gable span. In the first section, I'm going to set the gable span to height divided by 2. And if the width is smaller, I'm going to set the gable span to width divided by 2. Now I can use the parameter gable span to control the roof section's width parameter. Ta-da! Now I've exposed a bunch of other parameters on this roof node, and these parameters are cosmetic. They don't affect our logic script, so I'm not going to talk about them. The next mesh I created is the gable end walls, and again, I'm not going to go into detail, but you can see it's a series of shape mergers that combine the 2 halves of the roof with a wall section below. Now there are extra steps here because I'm expanding the individual shapes to make sure all the shapes spill over each other, merging them, and then shrinking the resulting merged shape back down to the right size. It took trial and error to extract the shape that I wanted. You can't see all of that here because a lot of that process is being done within the input and outputs on individual nodes. From that merged gable wall, I'm cutting out a window. Again, I'm skipping a few steps. I extrude the end wall facing out. Now I've used the window hole to create a 2-sided flat polygon and added the window material. So the wall and window meshes are routed through a grouper. And they're not inside the grouper, they're just routed through it. And I have routed the grouper into a pair repeater. If you're following me so far, I now have 2 gable end walls. They get their width from the short wall on the cottage, which is my gable span parameter. But I need to add another parameter on my logic node to set their position so they line up with the ends of the long wall. So back on my logic node, I added a new parameter called long span, which will give me half the length of the long wall, whichever that wall happens to be. It's just going to give me the number. The pseudocode adds 2 more lines inside the conditional blocks. So now when width is greater than the height, we're setting the long span to half the width. When the width is less than the height, we're setting the long span to half the height. I route this parameter to the pair repeater's separation parameter and subtract a little since these walls are free-floating. This adds some detail and scale to our cottage, and it gives the roof a nice overhang. All right, one more problem to solve with these end walls, and that's the Y rotation of this pair repeater. When the gable switches to the other side, the end walls need to rotate 90 degrees. Now, if you're starting to see the pattern, I added another parameter to the logic node. I called it something clever like gable rotation Y. And then I explicitly set this parameter to 0 or 90, depending on which side is longer. So now my pseudocode adds set gable rotation Y to 0 and set gable rotation Y to 90 right there in the conditional blocks. So my logic script is growing, but so far it's still pretty easy to follow. The 2 conditional blocks are mostly the same. They just have some small tweaks to the script depending on which condition gets triggered. Are you still with me? Okay. It's pretty easy so far, right? Okay, at this point I decided to add an optional 3rd gable. This took a little rewriting of my turtle script. And remember, this is the node that draws the long walls only while skipping over the short ones. So I added a new parameter. I'm sure you're surprised. I changed it to a bool and called it front gable. I need to find the specific wall where this new mid-gable will appear. It's going to be one of these long walls gets replaced with inside each conditional block. Okay, since front gable is optional and a bool, I need to add both true and false conditions to both sections of my script. So all in all, I'm adding 4 new if statements to my script. 1 true and 1 false when the width is longer. 1 true and 1 false when the height is longer. With a little experimenting, I found which walls need to be replaced in each section. And I'm nesting one of my bool if statements around the existing wall, and this is the condition that will be false. Okay? So if not front gable, draw the bottom and end if, and down in the other section it's if not front gable, draw the left side and if. Now next to it I'm going to add the true condition, and inside that block I add the turtle instruction for the shape with the mid gable, and obviously there's a little more to it because the gap in the long wall needs to adapt to the size of the gable, but you get the idea. It's going to be if front gable, and the true is implied, if front gable, draw the bottom with a mid gable, and if. And on the other side it's if front gable is true, draw the left side with a mid gable, and if. Spoiler alert, I had issues when the height and width were equal. My mid-gable broke the model, so I added 1 more conditional to turn off the magic gable at the top of the script if the sides are equal. So that's if height equals width, set front gable to false, and end if. Now I also edited the other conditional. So, it's if width is less than height. Although if it's actually equal, it would never reach down here. It's going to be handled by the first one, and the front gable would be turned off. But I'm going to change it anyway, just so I'm consistent. All right, I have 1 more engineering problem to solve, and that's this 3rd gable end wall under the magic gable. Okay, so I started with the existing gable end wall, cut out a doorway, and I made a new 3D mesh group. This gable positions itself a little differently. Its width is based on the short side, but the distance on this one should also be the short side. And I'm already calculating it with gable span, so we're halfway there. Now I subtracted a little off that distance so it matches the other gables, and I get that nice overhang. Now, I thought I'd be able to reuse that gable rotation Y parameter, but that didn't work out as easily as I thought. The new gable rotated, but it rotates 90 degrees, and its pivot point is under the center of the cottage. So instead of moving to the other wall, it just spun like a revolving door under the gable. So this is a different mechanical problem. At this point, I think you're starting to see there's infinite ways to solve these problems, and that's why this isn't a tutorial. Instead, I'm showing you how I solved a series of individual mechanical engineering situations by going back to the logic node, adding another control parameter and a few lines to my conditional blocks to set those parameters. Now my graph is a plate of spaghetti. It has relation wires strung all over it, but all the conditional parameters connect back to this one logic node, so it's pretty centralized. On a small model like this, it's really not that bad. I could keep adding to the script and adding more parameters as I go forever. And that's when I started thinking there's probably a better way to do this, rather than having a list of hundreds of parameters. So my logic node is malleable. I can get it to do whatever it needs to do, but it's not very modular. I can't move this script to another model. There's no reason to save this node to the library for reuse, its script is specific for the mechanics on this model. Yeah, that's fine. That's what we needed. But here I'm solving another problem and another problem. So let me show you how I simplified this. Now, the actual problem is I need to flip this third gable wall group. And what I decided to do was just to make a second version of the group. One for when one shows up when the width is greater, the other shows up when the height is greater. They don't rotate at all, they just turn on or off depending on which direction the gable is facing. So the joy of nodes means it costs nothing to create an identical grouper facing a different direction and wire the same mesh nodes to both. When one grouper turns on, the other turns off, and when the gables switch, the other group turns on and the first turns off. Now maybe I should have done this from the start. If I'd planned ahead, I could have routed the entire model through on-off switches. Well, I'm not going to redesign the whole thing at this point, but what I did was, you guessed it, I went to my logic node and I created a couple of more parameters. This time they are bools, since they will act as on-off switches. For the last time, I edited the logic script to turn on and off these bool switches. My final pseudocode looks something like set gable z false and set gable z x true. And under width is less than height, it's setting the z gable true and setting the x gable false. Now I routed these new bool switches directly to each of the grouper nodes enable bool. Each grouper is turned on or off according to the gable's logic, and when one grouper is on, the other grouper is off. Okay, so let me wrap this up. I made my model a little smarter with a custom turtle script on a centralized logic node, and that node controls the other nodes on the graph. I added parameters to nodes wherever I needed them, and I related them all back to the central logic node. My smart node is just a simple logic switch, but it changes the model in a few ways. It substitutes a different set of turtle instructions. It calculates new values on some parameters, and in other cases, I just set explicit values with the script. I also created Boolean switches that toggle options on and off on the model. Your logic script can grow as the model grows, and you just solve each little problem as it comes up. But in a bigger model with lots of options and mechanical configurations, you'll probably want to start using groupers and Boolean switches to turn on and off entire sections of the model. Now, one word before I go. While I was making this video, I contacted the developer with a couple of questions, and by the next official release, we'll have another more elegant way to toggle sections of the model by scripting in a channeler node, which I haven't even shown in this video. Now, that feature is coming in. It's currently in the Archimatix beta, so expect it to be officially released in a few weeks, probably by the time you're watching this video. And I will follow up with another tutorial when that goes live. My final message here, the moral of this story is, there are lots of ways to solve mechanical problems, and I hope I gave you some ideas, and you are already thinking about how you can make your models smarter too. Thanks for watching, everybody. I will see you next time.